So I have shared my screen. I hope everybody able can be able to see that screen. So yesterday we were talking about how a select statement will process in the database. Then we talked about what are the logical structures that are there in the database, and we discussed all those things. So just remaining once again about logical structures. So we have totally 4 logical structures, starting with the table space, then segments, extents, and the data blocks. So we started with the bottom portion, like Oracle data blocks, where we understood that Oracle data block is nothing but the location or the place where the rows inside the table will be stored, and a group of blocks we are going to call it as extents, and a group of extents we are going to call it as segment, and a group of segments we are going to call it as table space. And pictorially we can represent that in this diagram, where you can see the bottom portion we have multiple blocks, and combining those blocks we have extents, like extent 1 and extent 2, and combining those extents we have segments, and multiple segments will form a table space. So that is what we understood. And also we discussed about what are all the mandatory table spaces that are required. So from 10G onwards we have 4 mandatory table spaces. The first one is system. Whatever the base tables that we are talking about, so those base tables are going to store in this table space. And then we have sysops table space, which is newly introduced in 10G. And this table space is also going to store some base tables, but basically those base tables are required for report generation. If you want to generate the performance report of the database, or you want to generate some other report out of database, then these base tables which are residing in sysops table space are going to help you. And then we have temp table space, which is basically used for sorting the data. So whenever user issues order by clause or group by clauses, basically Oracle is going to use this particular table space. And then finally we have undo table space, which is going to store the older values or the before images we say, and these values are going to help us in doing the rollback of the transaction, or sometimes during database recovery also. So that is what basically we have with 4 mandatory table spaces. And we also understood a point that apart from these 4 table spaces, we can create, as a DBA we will be creating multiple other table spaces, and which we call it as non-mandatory table spaces. So whatever these 4 table spaces are mandatory table spaces, apart from that, as a DBA we will be creating non-mandatory table spaces, and all the user data will be stored in those non-mandatory table spaces. So that is what we understood about the table spaces and all. So let us start with the point how a DML transaction will process in the database. And I am taking an example here. DML transaction could be an insert statement or delete statement or an update statement. But to have a more clear understanding, I am taking an example here. Let's suppose a user has executed a update statement, and that update statement is basically changing a particular column value from a value of 100 to 200. So let's say you are changing the value from 100 to 200. So when user issues this update statement, how that will be processed in the database. So let us go and try to understand that. So the few first initial points will be same as our select statement processing. Like user process will be handing over the information to user process will be handing over the statement to server process, and then server process will be receiving the statement, and then server process will send the statement to library cache. Their parsing will take place, and once parsing got completed, then optimizer, there will be a component called optimizer, and that component is going to basically generate the best execution plan. And by taking that best execution plan, server process will come down to PGA, and the statement will be executed here, and then server process will start searching for the data in the LRU list. And if the data is not available in the LRU list, as I said, server process is going down to database, and it is going to pick up the data, and it is going to copy to the top portion of the database or LRU list. And this data reading and writing will be done in the form of blocks. So we also understood what exactly is a block and all those things. The standard block size is 8 KB, so we understood all those points. Now till here, whatever we discussed is a select statement processing. So server process, once it starts searching the data in the LRU list, what it will do is, if the data is not available in the LRU list, server process will come down to database, and from database it is going to copy the data. Now here one extra step is, normally if it is a select statement processing, then server process will copy only one block which contains the data. So suppose user is asking for a particular row, and that value is having that particular column or that particular row is having a value of 100, then only the block which is containing that 100 value will be copied to LRU list. But because this is a DML statement processing, what server process will do is, along with the block which is having the value of 100, it is also going to copy one more block which we call it as undo block. So, and this block we call it as data block. I am representing that with D, and the undo block I am just representing with U. So normally in select statement processing only one block will be copied, that is data block. But when it comes to DML processing, two blocks will be copied. One is data block with the value of 100, and the other block is undo block, which is an empty one. And once these two blocks are copied to LRU list, again these two blocks will be copied to PGA. So the same two blocks will be copied to PGA. Now what could be the reason? So why we require to copy those two blocks to PGA? Because LRU list, as you know already, yesterday we discussed it is going to basically follow LRU algorithm. So if more and more recent data is coming in, then what happens is, these blocks may get aged out, and once they will be coming down to the bottom portion of LRU list, they will be removed from the memory. So, and if those blocks got removed from the memory, then this update statement will not work. So that's the reason what Oracle will do is, once the server process copies both the data block with the value of 100 and one empty undo block, then both these data block and undo block will be again copied to PGA. And after copying to PGA, then it is going to do some modifications. Let us see what those modifications are. So this is what the modifications that happens in the PGA. So what is happening here is, basically whatever the value 100 is there in the data block, this value you are going to copy that to undo block. So why we require to copy that value to undo block? Because we know already yesterday that undo table space is going to store the older values. Suppose user issued updating a column from 100 to 200. Suppose the value got changed, but after that user said roll back, then what happens? Instead of 200, again 100 will come into picture, right? So that means we need to store the older value of 100 somewhere in the database, and that somewhere is nothing but our undo block. So what happens in PGA is, whatever the older value that is there in the data block, that is 100, so that value will be copied to the undo block. And once that part is done, then the new value, which is 200, what user is asking for, so that value will be inserted into the data block. So basically here I can say there are two changes happen. One change is inside the data block the value was changed from 100 to 200. This is one change I can call it as, and empty undo block is now filled with a new value, or empty undo block is now filled with a value. This is one more change. So that means totally in our database or in the instance section, two changes occur. And what Oracle will do here is, once these activities got once these activities got completed in PGA, then whatever the changes happen, like the data block value changed from 100 to 200, and the undo block got changed from an empty or null value to not null value. So these two changes will be recorded into a location, or will be recorded into some form of input. So it is something like you are maintaining a log for these changes. So an example I can give is whenever you want to okay, so whenever you want to visit your friend who is working in some company and all, so it is not possible directly to contact your friend. You need to go through the security. And what these security people will do is they will make a note of your name, then your mobile number, and from where you are coming, at what time you came to meet your friend. So they will register all these details for record purpose. So in the similar way, there are two changes happen in the database, and these two changes will be recorded in the database. So why that changes will be recorded? Because in future if something goes wrong, we can able to retrieve the information with the help of these records, and these records we call them as redo entries. So whatever the changes that happen to the database or the blocks will be recorded in the database, and those will be recorded in the form of a component which we call it as redo entries. So the definition of redo entry says a single atomic change happened to the database is called as a redo entry. So a single atomic change, that means the change should be single, as well as atomic means unique. So any unique change that happens to the database, we call it as redo entry. And here in this situation, two changes occurred in the database. That means two redo entries will be generated. And as I said, redo entries are nothing but keeping the track of what you are doing in the database. So everybody got understood about this redo entries, or anyone is having any queries? Okay, fine. Let me repeat that once again. So what I am saying is the value, both the data block and the undo block, which were first copied to LRU list. So those two blocks will be copied to PGA, and in PGA what happens is the older value what is there in the data block will be copied to undo block to here, and whatever the new value that user is asking to insert, even that value will be inserted into the data block. Now with this what we can say is there are two changes occurred in the database. So what are those two changes? One is the data block got changed from a value of 100 to 200. This is one change. And undo block, which is having a empty, so which is basically empty earlier, is now having a value of 100, and this is a second change. So what Oracle will do is, because two changes occurred, it is going to record this information okay, in the form of something called redo entries. So basically redo entry is nothing but whatever the changes happen in the database, that will be recorded. So here two changes occur, so that's why two redo entries will be generated. Suppose if 1 lakh changes occur, then there will be 1 lakh redo entries, so something like that. And what basically a redo entry contains, so even you need to know about that information. So let me show you that thing. So what information that a redo entry will contain is, redo entry will contain the below information, like it will contain the table name, so on which table you are going to perform this changing the value. Suppose in our case, let's say we changed the value from 100 to 200 in a table called T1, let's say. So then in our case what happens is, it is going to record what is the table name, then it is going to record what is the table space name, because definitely all the tables are going to reside under a table space. So let's say my table space name is my data, then it is going to record what is the block ID in which this change happened. So for example, the block ID is 1889, and then it is going to record the date and the time when this change happened. So the date and time, let's say just now I performed that, so it will be something like 13 July 2013, and the time would be somewhere around let's say 20:45 PM IST. So this one will be recorded, and then it is going to even record what is the new value that you have inserted. So in our case, the new value that was inserted is 200, so that will be recorded, and it will also record whether the transaction was committed or not. So either if the user issues commit, then it will be Y, or if user has not yet issued any commit, then it will be marked as no. So this is how basically the information will be stored in the database. So all this information will be combined into a single entity, and that we call it as a redo entry. So basically you are tracking down what is happening in the database. So is that clear? So anyone is having any more queries before we proceed further? Okay. So as I said earlier, why we require this information to be tracked by the database? It will be used for future purpose. If at all you want to track down what happened in the past or something like that, you can basically make use of these redo entries. So that is the advantage that we have. So where the redo entries will be generated? Definitely in the PGA itself. Because the changes happen in the PGA, redo entries will also be generated in the PGA itself. Now after that, what happens is, whatever the redo entries that are generated in PGA, so whatever the redo entries that are generated in PGA, these redo entries will be copied from PGA to a component called log buffer cache. So hope you people can see that I have drawn a line here. So whatever the redo entries that are generated, why I have why I have kept two circles here is because we are taking an example that two redo entries will be generated. So that's the reason I have taken this. So the two redo entries which got generated, these redo entries will be copied to log buffer cache. So who is going to do that copy? It is again server process, and once that copy was done, then whatever the blocks that were modified, so those are redo entries, but still the blocks which got modified. One is data block and another one is undo block. So whatever the blocks that were modified, these two blocks also will be copied by server process to write list. So that means two things here. Redo entries will be copied to log buffer cache, but the data blocks, or sorry, but the blocks which are modified will be copied to the write list. So either redo entry copy or the block copy will be performed by server process only. And once those blocks are copied to write list, for example, let's say server process copied both the blocks. So this is data block which contains the value of 200, let's say, and this is undo block which is having the value of 100. So then what Oracle will do is, once these two blocks are available in the write list, you can see a background process here by the name DBWR, so which stands for database writer. So the name itself is telling you it is going to write into the database. So this database writer is going to take those blocks and it is going to write them into the data files. So what happens once server process copies the blocks to the write list, from write list your database writer background process, it is going to copy or it is going to write that information to data files. But well before database writer is going to do that activity, there is another background process called LGWR, which stands for log writer. This background process, what it will do is, it is going to copy the data from the log buffer cache and it is going to write them into redo log files. So what happens is, before DB writer writes, log writer is going to record that information into redo log files. So that means first log writer will write, then DB writer will write. And this is always the same way how it happens. That means never DB writer will write first and then log writer will write. In any of the situation, first always log writer will write and then DB writer will follow that. So this is the standard fundamental rule that Oracle architecture follows. So once your log writer completes writing the data from log buffer cache to redo log files, and once the database writer copies this two blocks into data files, that means your value was permanent in the database now, because until unless the data is available in the write list, and the write list is a part of instance. And we already understood in the beginning classes that instance is volatile in nature. That means once you restart the database, nothing will be there in the instance. So because instance is going to reside on the RAM. So that's the reason you cannot have these two blocks in the write list. Definitely you need to push them into the database. So DB writer is going to help you in that. So once DB writer completes writing the data to data files, we say that our data is now permanent in the database. So have you guys understood the flow? Okay. So we have a question here from Raghu. He is asking, like, after the transaction got committed, let's say user has issued a transaction or a commit, then what happens to the undo data? Now before explaining about this, I just want to ask you a question. For example, user has updated a value from 100 to 200, then user issued commit. That means 200 will be permanently written into the database. Now after you do commit, can you issue rollback? So that was my question. User issued a update statement which changed the value from 100 to 200. Then user issued commit also. After that, can we issue rollback? Yes, definitely not possible. So once you say commit, there is no concept called rollback. That means once the user issues any commit, we don't require the data in the undo table space. So that is the reason Oracle will remove that 100 value. So that means the data or the older values in the undo table space will be there till the time user issues commit. Once the user issues commit, there is no point in maintaining the data. That's the reason Oracle will remove the data from the undo table space. So is that point clear? And of course, more about this we will be learning in undo management, but it is just to give a brief idea. So once again, let us go and see the flow, how exactly it is going to work in the database. So user process is going to issue the statement and server process is going to receive the statement. Then server process will send the statement to library cache. Their parsing will take place. Optimizer is going to generate the best execution plan, and by taking that execution plan, server process will come down to PGA and it will get executed there. Then server process will start searching for the data in the LRU list, and if the data is not present in the LRU list, then server process will go to database, and while copying, it is going to copy two blocks. One is a data block and the other one is undo block. And once the data block with a value of 100 and once an empty undo block, both were copied here, then both the blocks were again be copied to PGA, and in PGA the necessary modifications will take place, like the value of 100 will go to undo table space or undo block, and a new value what user is asking for, that is 200, will be inserted into the data block. And then we say, two changes happen in the database. One is for data block and another is for the undo block, and Oracle will record these changes for future use, and those changes we are going to call them as redo entries. So the redo entries which got generated in PGA, so these redo entries will be copied to log buffer cache by server process, and after that server process will copy the modified blocks to write list, and from write list there is a background process called database writer. So that background process is going to write the data into data files, but well before database writer writes that information, there is another background process called log writer. So this background process is going to copy the data from the log buffer cache to redo log files. Now again, if somebody asks you what is the reason in writing the content from log buffer cache to redo log files, that means why log writer need to copy the data. If somebody asks you a question at this moment of time, just say it is for recovery purpose. So down the line, when we look at SMON processing, you will be understanding more about it. But as of now, you can remember why we require that data to be there in the redo log files. It is for recovery purpose. So this is how a DML statement will process in the database. So this flow is the same even if you go for insert statement or delete statement. So any queries before we proceed further? Okay. So then let us go and understand the next one, how a DDL statement will work in the database. So like DDL statements, like what you have create or alter, create, drop, truncate. So let us go and see how they are going to process. I hope everybody can able to see my screen. So and you can read the points over there. So DDL statement processing is also same as DML processing, as internally all the DDL are DML statements to the base tables. So that means whenever you are creating some table, then the underlying or the base tables. So we have already discussed about what is base table and all. So whenever these DDL statements were issued, then the underlying base tables will get updated. For example, if you are creating a table, then one row will be inserted into one of the base table. Or if you are dropping one table, then one row should get deleted from the base table. Or if you are adding one new column, then also the base table will get updated. So base tables are nothing but the dictionary information of database. So every time you do some change, the dictionary will get updated. So that is the reason even the DDL statements will be exactly processing like a DML statement, because those will be acted as DML statements for the base tables. And the second point says, for every DDL statement, base tables will get modified with update, insert or delete statements. That is what I explained. And because of this reason, in case of DDL also, undo will be generated. So whenever you have these DML statements in place, definitely undo will be generated. So in the case of DDL also, some undo will be generated. So that is how we have DDL statement processing. Then we have something called components of Oracle database architecture. So basically this particular heading, or from this particular heading, the definitions for all the components what we will be seeing in the architecture were given. Like what is the definition of user process, or what is the definition of server process, then PGA, then what is instance. So I have given the definitions. So it can act as a quick reference whenever you attend the interviews. So let's say you have an interview tomorrow morning, and today night if you want to brief out your architecture knowledge, then you can just go through this. It will be much more advantageous, and all will be in a single line definitions. So let us start with this one. So starting with the first definition of user process. So we already understood about this definition. Whenever user starts any application, then one process will be executed in the background, and that process we are going to call it as user process. And then we have server process, and we also know the definition of server process. Basically, it is the process which is going to work on behalf of user process. So user process is going to just request for the information and will receive the information, but the actual work in the database will be performed by server process. And then we have PGA, which stands for Private Global Area, or some people can also call it as Program Global Area. So, and one point we already know, the first point which is mentioned there, which we already know, it is the memory which is allocated to server process in order to perform the execution of SQL statement, or to store some session information, etc., etc. So that is what basically PGA is. The memory which was allocated to server process is called as PGA. And what is the name private represents there? That means, I hope yesterday I said this, for every user process there will be a dedicated server process. Like if you have 100 users, there will be 100 server process. And each and every server process will have its own PGA. So that means the PGA belonging to first process will not be equals to the PGA of the second process, and that is the reason we call it as private. So I will be having my own PGA, you will be having your own PGA, or some other user will be having their own PGAs. So that is what basically the reason why we call it as private. And point number 2 is going to say that the size of the PGA is going to define with the help of a parameter called PGA underscore aggregate underscore target. So there is a parameter that we need to define to whatever be the size. Suppose if I say PGA underscore aggregate underscore target equals to 300 MB, then what operating system will do is out of its RAM, it is going to allocate 300 MB to PGA. So whatever the value I specify, that much amount of MB or that much amount of GB will be given to PGA from the RAM. So that is what operating system will do. But the question here is where we are going to define this parameter. So let's say we understood the point that the size of PGA will be defined by this parameter, but where exactly we need to specify this. So we need to specify this under a file called parameter file. So if you look at the architecture diagram, so in this diagram, I hope everybody can able to see this. There is a component called parameter file. So let me highlight that. So here it is. So there is a file, physical file, we call it as parameter file. So in this file, we need to put down that line. So saying, my PG underscore aggregate underscore target should be this much. So basically what Oracle will do is, while it is going to start the database, it is going to read this parameter file and it is going to allocate, or it is going to request the operating system to allocate that much memory. And let me show you an example how this parameter file will look like and all. So you can see my screen. Okay, so I will discuss about more details about parameter file and its location, the naming convention and all later. But if I open my parameter file, this is how you can see different parameters that you will be having it. So like you will be having a parameter like what is the database name, and you will be having this is what we are discussing about PG underscore aggregate underscore target. And here you can see we have defined some value like 293601280. So that value is basically in bytes. You need to convert that into MBs. So it's basically around 290 MB. So if you convert that into MBs, so this is how we are going to put down one line in parameter file. So parameter file is a text file, and that's the reason here I opened it with VA editor. So even if you want to change also, because this is a text file, definitely you can go and change the value. So suppose I want to change this value to 500 MB, then accordingly I can change it. So as I said, what happens is basically when you are starting up your database, Oracle will read this parameter file contents, and accordingly it will request the operating system to allocate the memory. So is that point clear with everyone, or any queries? Okay. So now let us come back and go through the third point. So before 9i, what we used to do is, instead of using the single parameter which was mentioned in point number 2, that means here we have a single parameter. So instead of this single parameter, in 8i or below 8i versions, we use it to define 4 or 5 parameters. So like work area, then bitmap work area, etc. etc. Now what is the reason why we are going to define these many parameters in 8i, and why we changed that strategy and we are using only one parameter from 9i? So to understand that, you need to look at the diagram here. So this is the actual picture of the PGA. So if you just zoom into PGA, so PGA was actually divided into 5 components. The first one is user session information, where the information about the user, like what is the username and through which machine the user connected, and what is the IP address of the machine, and at what time the user connected. So all this information will be maintained in that particular area. And the next one we have is sort area, where the sorting of the database and all will take place. Like whenever user issues order by or group by clauses, then basically Oracle will do sorting in this particular memory, and we call it as sort area. And then we have work area, the below one. Whatever we discussed till now, like the execution of the statement will take place in PGA. So that execution is going to take place in this particular component called work area. Then if the statement is using any hash functions, those functions will be dealt in hash area. And if the application code is having any bitmaps, like they are using some bitmaps like 0 and 1 or something like that, then those will be processed under bitmap work area. So we are least bothered about hash area and bitmap work area. So we need to just concentrate on work area and sort area. So as I said, work area is nothing but the location where the execution of the statement will take place, and the sort area is a location where sorting of the data will take place. So what we use it to do in 8i or below versions is, for each and every portion of this memory, we are going to define individual parameters. Like if you look at this parameter work area size, so that is going to define some size. And for bitmap work area we need to define some size, and sort area we need to define some size. So for each and every memory component we use it to define some size. So this is still 8i and all. But people or the DBS who are working with those versions observed that there is some complexity involved in managing these components. For example, you have given work area size as 100 MB, and you have given sort area size as 50 MB. And let's say now you require 25 MB extra in sort area. So work area you have given 100 MB, sort area you have given 50 MB, and let's say now for sort area you require 25 MB more. Then what you can do is, you can reduce the size of work area from 100 MB to 75 MB, and whatever the reduced value is there, you can add the 25 MB to sort area. So this more of a kind of memory adjustment. So you are going to adjust the memory between several components. But the biggest problem in adjusting these memory components is, every time you do some change, you need to shut down the database. That is how Oracle is going to work in 8i version or below 8i versions. So if I want to reduce work area size, then I need to shut down. Or if I want to increase sort area size, then also I need to shut down. Or if I want to do any modifications to bitmap work area or hash area, even then also I need to shut down. But frequently we cannot shut down the database like that in real time. So that is the reason the DBS who use it to maintain these 8i databases and all, they use it to face lot of issues or lot of problems like this. So what Oracle has came up with a solution is, From 9a onwards, instead of giving these many parameters, we are going to issue only one parameter, that is pj underscore ideate underscore target. And this parameter, and what Oracle says is, if you set this parameter to some value, then automatically I will be taking care of the memory adjustment. So we don't require to do any memory adjustments as a DBA. Oracle itself will take care of the memory adjustment, and that too online. That means you don't require to shut down the database. So memory adjustment will be is automated, as well as it was being performed in the online mode. So two advantages we got from 8A PGA to 9A PGA. So everybody got the point what I am trying to explain? Any queries? So I'm just taking a gap after asking for queries, because you people are typing in so in the chat, so I need to wait for that questionnaire. Okay. So once, so that is how the memory portion was deal between across versions, and of course whatever there in 9.9 continued in 10G also, and even but there is a slight difference in 11G, which we will talk at a later point of time. So now coming to one particular thing. So we have been discussing about sort area, and as I said, the sort area of PGA is used for sorting the data. Like whenever user issues select star from table name, order by so and so column, or group by so and so column, then basically that sorting is going to take place in sort area. But if you recollect, yesterday or even beginning of the class today, I said sorting will take place in temporary table space. That means here now we have two statements. One is sorting will take place in PGA, and second one is sorting will take place in temp table space. So both the points are correct. How they are going, how they are correct. So we need to understand that. So just look at point number 5 on the screen. So if the data size is larger than the sort area size of PGA, then Oracle will make use of both PGA and temp table space. But if the data size is very small, or it is perfectly fitting into the PGA, then entire sorting will take place in PGA itself. So that is what mentioned in points 4 and 5. So point 4 says sorting will take place in PGA if the data is small in size, and this we call it as in-memory sorting. And suppose if the data size is larger than the sort area size, then Oracle will make use of both PGA and temp table spaces. And PGA is a memory, and the temp table space is in hard disk. So memory to disk is always an IO, and we already seen the point in the first day itself, that whenever the more number of IOs are there, then there will be a less performance or low performance from the database. So that is what the second line of fifth point says. So when Oracle uses both the PGA and temp table spaces, it will make, or it will need more number of IOs, and automatically the database performance will be degraded. So what is good for database is in-memory sorting. So as a DBA, we need to make sure that the most of the sorting of data is being taken place in the PGA itself instead of going to temp table space, because once Oracle starts using temp table space for sorting, then all these performance issues etc. will come into picture. So that is about how sorting will take place in the database. Then we have the definition of Oracle instance. So basically Oracle instance is a way through which the users either access the data, that means they will read the data, or they will modify the data. That means they will manipulate the data in the database. And already we saw this. Oracle instance is a combination of memory structures and background process. And starting with the memory structures, the first memory structure, or combinedly together all the memory structures, we are going to call it as SGA. So I hope you can see here. So we have a word, or we have a keyword called SGA. So what exactly mean by SGA? We have several memory components here, like the shared pool is there, then database buffer cache is there, log buffer cache, large pool. So we have so many memory components here. So combining these all memory components together, we are going to call it as SGA. And how can we define SGA? So the abbreviation says shared global area, and some people will also call it as system global area. So why we are going to call it as a shared? Because every user will use the same shared pool, or every user will use the same database buffer cache. So that means even 100 users are there in the database, all those 100 users definitely should use the same components. And that means you are basically sharing the memory component across all the users. So that's the reason we call it as shared global area. And as I said, some people will call it as system global area also. So the definition says it is the memory area which contains several memory caches which are helpful in reading or writing the data. So starting with the first one, shared pool. So shared pool contains the following components. One is library cache and another one is data dictionary cache. So you have already seen in the picture here, the above one is library cache and the below one is data dictionary cache. So what exactly a library cache contains? It contains basically the shared SQL and PLSQL statements. Or more clearly to say, library cache contains parsed statements, because parsing is going to take place in the library cache. We can say that library cache contains of parsed statements. Then we have data dictionary cache, so which we saw during user authentication. So data dictionary cache is going to store the copy of base tables, or we can also say it as dictionary information. But this information will be there in the form of rows, and that is the reason some people will call it as, or some books will refer it as row cache. So instead of data dictionary cache, you can call it also as a row cache, but it's very rare case. So I have not seen, many people are having the habit of calling it as row cache. And we don't have separate parameters to define the size of library cache and data dictionary cache. So we have only one parameter, that is shared underscore pool underscore size, and this is going to define the size of entire shared pool. That means if we have given shared pool equals to 500 MB, maybe library cache will be given with 250 and data dictionary cache will be given with another 250. So I am not saying that exactly 50% it will be divided, but somehow it will be divided in the database. So that is all about the shared pool that we have. Then we have the next memory component as database buffer cache. So this database buffer cache is again having two components, as you saw in the diagram. So it is having both the LRU list as well as the write list. So LRU list is having the data which you are copying from the database, and write list, just a while we talked about it, the modified blocks are going to be stored in write list. And apart from this, or I mean to say, there were some status given to the blocks inside this database buffer cache. Suppose you have created a new database, then definitely the database buffer cache also will be new. So every block which is there inside database buffer cache, because it is a fresh one, we call it as unused block. So you can see the status over there in the second point. So the first status of the block we call it as unused block. So what is meant by unused block is a block which was never used, means nobody touched this block till now. And when that is possible is only when you create a fresh database, because if the database is in use, some or other user or some other server process will definitely use the block. So this status you will be observing only when the database is freshly created. And as I said, once the database starts using once the users start using the database buffer cache, then there will be some status for the block as free. Now what is mean by free block? As you can read the description there, block is the block which is used already, but right now it is free. So any block which is occupied earlier, but at this moment if it is free, we are going to call it as free block. And just like that, if you have any block which is already being used by one server process, then we are going to call it as pinned block. And if any block got modified, then we are going to call it as dirty block. So that means whatever the blocks which are there in the right list, as I said, those blocks are modified blocks. So we can call those blocks as dirty blocks. So dirty blocks, yeah, is nothing but the blocks which got modified because of some DML statement. So these are the 4 status that we have. And point number 3 says database buffer cache contains LRU list and write list, which helps in splitting the modified blocks with other blocks. And the size of the database buffer cache, we are going to define it with the help of any one of these parameters. Like one is db underscore cache underscore size, and the other one is db underscore block underscore buffers. But the first one, db underscore cache underscore size, we need to use from 9A onwards. And if it is 8i database or below, then we need to use db underscore block underscore buffers. So that is how we are going to define the size of database buffer cache. And Raghu is having a question, to understand more about dictionary cache. So first of all, have you understood the point that data dictionary cache is basically going to store the copy of base tables? So is that point clear? Okay. So and what else more details that you are expecting? Because based on that I can frame the point. Yeah, that's what I said. The base tables will be stored in the database, but when you are accessing them, a copy need to be there in the instance. And to store that copy, we are going to make use of data dictionary cache. Suppose in the case of user connectivity, we saw that Pmon is going to first check for a copy of base table in data dictionary cache. If not, Pmon will go down to database and then it is going to copy from the database. So we have seen that. So it is going to, okay, more clearly about base tables, if I want to say, whatever the information that database is having, so it is going to maintain that. As I said earlier, as a human being, we will be having brains and we can understand or we can store some information. But it is not possible for a computer system to store that, right? So that's the reason basically it is going to make use of some memory area. For example, uh, let's say I installed Google Chrome in my Windows PC. Now, as a human being, I can remember that whether I have installed or not. But how your Windows operating system knows that this software was already installed or this software was not already installed? So how OS will know that? Any idea? Because OS doesn't have any brain, right? So anybody knows the answer? How exact? How Windows operating system knows that this software is installed or this software is not installed or something like that? Okay. So basically that is going to be done with the help of something called registries. Okay. So I don't know how many of you people know this command. So there is a command or there is a utility called regedit, registry editor. So registry is nothing but the place or the memory location on hard disk where exactly operating system is going to store about the information regarding every software that you install in the OS, or every user. Even if you create some users, even it is going to store that information. For example, so when you go to this, I hope everybody can able to see my screen. So if you go to this HKey local machine, then you click on this software, you can see all the softwares what you have installed here, including what I am discussing is Google Chrome. Okay, so where it is? Okay, somewhere it will be there. Let's not waste the time. All the things. Suppose Mozilla, instead of Google Chrome, let's take Mozilla. So this Mozilla information will be there, or if I install Oracle, so Oracle information will be there, or any other softwares. Okay, if I install VMware, that information will be there. So this is how Windows is going to maintain the information. In a similar way, Oracle is also going to maintain the information like how many tables are there in the database, how many users are there in the database, and which user is having privilege on which table, all these kind of information. So basically Oracle is going to store all this kind of information in the base tables, and whenever we require those base tables, Oracle is going to copy them to data dictionary cache. So I just tried with something. So have you guys understood? So should I take yes or no, because there was no response? So is that point clear?
Hi, Pawan.
Yeah, hi Raghu, tell me.
Yeah. How about data dictionary views?
Yeah, data dictionary views are something like, I'm not sure, you were there in yesterday's class?
Yes. Yeah.
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 Yeah, we discussed about few points like the base tables data will be in cryptic format, and we couldn't able to read what is there inside the base tables. Oracle has made them secure. So that's the reason Oracle has given us a chance that you can view the data with the help of views. So that is what basically we are going to do. And after the database creation, we need to execute some scripts in order to create those views. So for example, yeah, so this is what we discussed yesterday. Few points regarding the views. So we have two types of
No,
views.
no, no.
Yeah, go ahead.
Uh, I'm asking about where they are stored.
See,
Like, they,
Yeah, views will be basically stored in system table space only.
System table space, right? So
Yeah.
is there any relation between these base tables where user information, privileges, and all this information is stored in data dictionary cache?
Yeah, exactly. That's what I am trying to say. The data permanently will be stored in the database, but whenever required, Oracle will copy that into data dictionary cache. So basically, data dictionary contains a copy of these base tables. Now, one point we need to understand is Oracle will never use these data dictionary views. Okay. Views will be used only by DBAs in order to understand what is there inside database. Oracle can directly access base tables. For example, here that point was there. If I want to say, okay, so you can be able to see this fourth point here. So a try to modify the base tables may lead to the database corruption. That means we should never try to modify the base tables. Only Oracle processes are having the authority to modify them. So either to read them or modify them, only Oracle background process, like whatever we are discussing about PMON, then database writer. So all these will be having the authority. So views will be used only by DBAs in order to view the information. So is that clear? Okay. So that is how we have the things in data dictionary cache. So then we have log buffer cache. You can see on the screen. So just now we read a point in DML processing that server process is going to copy the redo entries which are generated in the PGA to log buffer cache. So basically log buffer cache is to temporarily hold that particular redo entries, and the size will be defined by a parameter called log underscore buffer. And there was a note so which says log buffer cache, shortly we can call it as LBC. So log buffer cache should be allocated or allotted with the smallest size than any other memory component in SGA. So you have a shared pool, you have database buffer cache and all other components. But out of all the other components, this component should be given with very small size. So then we have large pool. So large pool will be utilized or used during the time of RMAN backup. So what is RMAN and all, we'll be discussing it. So basically backup means already taking the copy or making a copy of the database. So when you are taking the backup of database, then you will be requiring, or especially through a utility called RMAN, you can make use of this large pool. And one more functionality large pool is having is it can dedicate some of its memory to shared pool. So suppose shared pool is getting out of memory and it is not getting enough memory, then what it can do is it can go and request some memory from large pool. So and once the problem got solved that the shared pool has sufficient memory, then again it will give back the memory to large pool. Again, as I said, it's a kind of memory adjustment. And the size of the large pool will be defined by large underscore pool underscore size. And then we have Java pool. So basically to execute any Java components, like you have some JDBC driver components or any small Java code that you have written. So all this can be done in Java pool, and the size will be defined using Java underscore pool underscore size. Now here you guys may ask me a question, why we require or why we have only exclusively for Java. So why don't we have a C pool or C++ pool and all? So one reason is Java is a independent operating system language. You know that already, and even Oracle database, in some parts of Oracle database, the code was written in Java. So that's the reason this particular pool was introduced. And then we have stream pool. So basically, we have a concept called database replication. That is, you know, uh, basically to copy the data from one database to another database in a timely fashion. So suppose you have one table and the rows are getting updated, and you want the same table with the same rows in some other database. You can create something called a replication. So you have two databases A and B. If you want the same data to appear in A and B, basically you can create a replication mechanism, and this replication mechanism can be achieved through different ways. So like we have Oracle streams, that is one way. We have materialized reviews, that is another way. We have Oracle data guard, that is third way. And we have recently Oracle Golden Gate, that is the fourth way. So like this we have different ways to implement it. But when you use Oracle streams, then you need to define a separate memory called stream pool. So that is what it is saying in the first point. It is a memory area used for replicating the database, especially when you are using Oracle streams. And this stream pool got introduced in 10G, and the size will be defined basically with the help of that parameter stream underscore pool underscore size. And suppose if you are using Oracle streams and you have not configured stream pool, then what Oracle will do is straight away it will go to shared pool and it will take 10% of the shared pool. But if already shared pool is occupied with some work and you are taking away some memory, then what happens is more burden will be there on the shared pool, and this may affect the database performance also. So that's the reason whenever you are using Oracle streams, it is a must that you need to configure stream pool. So if you are not using Oracle streams, then just simply you can define the size as 0. So that is how we have all the memory components in place. So any queries? Okay. So one small update I just want to give. Tomorrow actually I got some occasion to attend from my relatives side. So that's the reason I would not be able to take up the class tomorrow. So let us have the class on Monday, again same timings. So you guys no need to worry. We are going in good pace, and that will not create any problem. So that is one update I just want to give. So any more queries or otherwise we can stop at this point, and next we have response processing, which is quite important. So which we'll be discussing it on Monday. So before we wind up, any questions you have, just ask me. Yeah, actually, like Pawan is sorry, Vishnu is taking care of that thing. I have already sent him the document. Probably you can just, if you have number, you can just call him up, and or you can send out an email, because I am done from my side. So actually he is having the authority to create the soft copy, because each and every soft copy will be having your name as the watermark. So so just check with him. So if you want, his email ID is pavan@kannatechnologies.com. Okay, so then let us meet on Monday once again. And meanwhile, if you have any queries, you can write down an email to me. So pawanDB@kannatechnologies.com. So see you guys on Monday again at the same time then. So have a wonderful Sunday and bye.